we are dealing with section 2.5, which is about parallel and perpendicular lines. Okay, so let's remind ourselves what parallel and perpendicular lines look like. So lines like this that run kind of next to each other and will never cross, they'll never intersect, those are parallel lines. Okay, this one you can't really tell exactly, but lines like this, what happens is this makes a right angle or a 90-degree angle, and those are perpendicular lines. So these are parallel, and these are perpendicular. Okay, now let's look at the slopes of these. And I know that some of our homework we were finding slopes and things, but if you remember, to find a slope, we just need to find 2 exact points, and these points are marked. But look at this slope. It goes down 2 and to the right 3. So what is the slope of this first line here?
2 over 3.
And since it's going down,
Negative
2 over 3. So negative 2 over 3 is the slope of that line.
Mm-hmm.
Now what about this other one? Notice what it does. Do we see it does the same thing?
Yeah. Mm-hmm.
Down 2 and over to the right 3. So the second slope is exactly the same, and that is true about all parallel lines. If 2 lines are parallel, their slopes have to be the same. Yeah.
So you can go the other way too, right? Did you say that last time?
What's that?
The
You mean from this point back to here?
and go that way and then down, or no? You can't. You
Which-
can't go this way, like over.
Oh, you mean this way,
Yeah,
and then down.
yeah.
I don't do that because the top number on your slope is always the up and down. So rather than, because yeah, I mean, this is 3 and negative 2, but when we do our fraction, it's negative 2 over 3. That's the
So
fraction.
just not.
So I would always go up and down
Okay.
first.
Thank
Yep. But yeah, you could. I mean, it's the same distance and the same directions. You just have to remember for your fraction which one goes on the top.
Okay.
Have
Okay.
you ever tested all the lessons, like 1, 2, 3, 4, 5? Did you do that at the end of the semester? No.
You mean for like the semester final?
Mhm.
Yeah, we'll do that at the end of the semester.
All of them? All of them?
Well, I mean, it's not going to be, I can't possibly test all of them because that would be too long of a test. But by the time we get to the end, hopefully we at least somewhat remember. We're going to review. Don't worry, we'll review.
I'm worried.
Like, do you know what happens the last week? The last 2 weeks. So the very last week is the semester final. Second to last week, we take the last test, and then the whole rest of the time we can review for the semester final. If people decide they want to stay, and then some people did stay all the way till 10 o'clock last semester, and then some people are like, I'm out of here because class is over and I took the test and whatever. Okay, so anyway, but over to this one, perpendicular. Let's count. This one, what is the slope on this one?
Negative 3 over 2.
Negative 3 over 2. So the first slope here is negative 3 over 2. Now notice the slope on this one, because these are perpendicular. What's the slope on that one? You went from
2
here,
over 3?
yeah,
2.
up to
3.
over 3. So how do these slopes compare this time? They're not equal, right? If they were equal, it'd be parallel. But what do you notice about these two slopes?
Opposite.
They're opposite signs.
One's
One's negative, one's positive. And then what do you notice about the fraction? It's the reciprocal, right? The numerator
Yeah.
becomes the denominator becomes numerator. It's the
Yeah.
reciprocal. So 3 over 2 becomes 2 over 3. Or sorry, negative 3 over 2 becomes positive 2 over 3. And that's always true about perpendicular lines. Their slopes are what we call opposite reciprocals. So you're going to change the sign, and then you're going to take the fraction, and you're going to flip the fraction. Okay, reciprocal. That's right. Oh, reciprocal? Well, it'll probably be on here.
Okay.
It's going to be on here in a minute. There it is. Let me erase this so that you can see
I
it.
was like,
I was just telling you ahead of time. You know, it's a teaser. So notice that the lines that are parallel have slopes that are equal, and that is always true. Always true. Then perpendicular lines have slopes that are opposite reciprocals of each other. So whatever the sign is, it changes. And then whatever the fraction is, it changes. Okay. I feel very exposed here. I need to just put this. Although there's a spider right there, so that's great. Put this back up. It's a small spider. I don't think it's going to kill me yet. Okay. You got that reciprocal word spelled yet?
Reciprocal.
You said it like 50 times.
All right. So find the slope of the line parallel to this line. Now remember,
This scared me so much.
looking at it right now, we don't know what the slope is, right?
Mhm.
We've got to rearrange it. If you remember,
Mhm.
in order for us to know what the slope is, we want to put it in this form right here. Y equals mx plus b. That's supposed to be an m. It got distorted.
I
Okay.
almost fucked that.
So y equals mx plus b, and we want to rearrange that equation and put it into slope-intercept form. Y equals mx plus b. So the goal is get the y by itself, right? So if we're looking at this, we're trying to get this by itself. What do we get rid of first?
2x
The minus 2x. How do we get rid of that minus 2x?
plus 2x.
We add 2x, right? If they're subtracting, to cancel it out, we need to add. So add 2x. So now we have 5y. This is gone. And we put the x first because we want it to fit into this format. So 2x plus 7. And then what else do we have to do?
Divide by 5.
Divide by 5. Because they're multiplying by 5, we're going to divide by 5. And remember, we divide everything by 5. What's funny?
I'm always gonna remember that I didn't do it in the test.
Oh, you didn't divide everything? Okay. So now we have rearranged this. And by looking at this, okay, let's go back up here for just a second. This is slope-intercept form, right?
Mhm.
Which one of these is the slope and which one is the intercept?
The m.
The m is the slope, right?
Mhm.
And this is the y-intercept. That's some review. So if we're looking at this, what is the slope of this line?
2 over 5.
2 over 5. Okay, so that's the first thing we need to know. What's the slope of this line? Now we can answer the question. We want to find the slope of a line parallel to that line. So if you don't remember, look back in your notes just a little bit. What do we know about the slopes of lines that are parallel?
They're the same.
They're the same. They're equal. Right, the lines never meet, but they don't meet because the slopes are equal. So if this slope is 2/5, what is our new slope going to be for the parallel line?
The same 2/5.
2/5. Okay, does that make sense? Because if they're parallel, the slopes are equal. So if we know that one's 2/5, our new slope will also be 2/5. Okay, and that's all that this question was asking. Find the slope.
Do we have to draw a graph? No.
No, we're just finding the slope.
I think that's where I get confused.
Yeah, the words
What?
make us confused.
Yeah.
Well,
When
you
you're
just-
here, it's piece of cake.
But well, it just
Then I
says
go
find
home.
the slope. That's all. Find the slope. Stop.
Piece of cake. Okay.
It's like
I didn't say it was a piece of cake. That was somebody else. All right. So
for me.
here's another one. Excuse me. Same beginning though, right? Because now we're gonna find the slope,
Find the slope.
but of a line that's perpendicular.
Perpendicular. So different.
Okay. But we have to still figure out what the slope of this line is, right?
Mhm.
So we do the same thing. We want to put it into this form. We have to get the y by itself. So here's our y this time. They're moving it around on us. What do we have to do first in this one?
Subtract 3x.
Subtract 3x. Now, one thing that's very important, guys did a great job. This is a positive 3, right? To cancel it out, we have to subtract 3x. This negative goes with the 4.
Mhm.
So subtract 3x. So that cancels out. We get negative 4y is still there. And remember, we put the x first, so negative 3x plus 2. What else do we have to do?
Divide
Divide by
negative 4.
negative 4. And we divide everything by negative 4. So that cancels. We have y equals a negative divided by a negative makes that positive 3/4 x. And this becomes negative 1/2. Now again, the only thing we're worried about in this problem right now is what is the slope? So what is the slope of this line right here?
3/4.
3 over 4, 3/4. Is everybody okay with that?
Which means it runs 3 and then it goes.
It goes up 3 and over 4. Okay, so now for perpendicular, remember we don't use the same slope, that's parallel. What is our new slope going to be if this one was 3/4?
-4/3.
You switch the sign.
So -4/3.
Yeah, so this is positive, so our new one will be negative, and I'm just going to put, this is actually the symbol for perpendicular. It's like an upside down capital
okay.
T. You don't have to put it there in the computer, you'll just enter the number, but just to differentiate between these two, this is the first one. So our slope is going to be, this was positive, so ours is going to be negative, and this is 3/4, so ours is going to be 4/3. Right? You got to take the reciprocal, 4 over 3. Okay, does that make sense? So that's the key. Parallel, same slopes. Perpendicular, the slopes are going to be opposite signs, and the fractions are going to be reciprocals of each other. Okay. Any questions on that? Just identifying the slope?
How do you bring down the
Yeah.
3x?
Right here?
Yeah.
Okay, because what we need to do when we first start with our equation is it's in what we call standard form or general form. And we don't, just looking at this, we don't know what the slope is. And we need to figure out the slope. So we want to put it into this form, which is our slope-intercept form. And to put it into this form, we've got to get the y by itself. So that's our goal right here is I've got to get the y by itself. So to get rid of this 3x, we subtract the 3x. So if that cancels out. And we have to do the same thing on the other side. Remember, our equations have to do the same thing on both sides. So now all we have left on this side is the -4y right here. And we have the -3x plus 2 on the right side. And then we have to get rid of this -4 to get the y by itself. So we divide by -4. And then that gives us the rest of that. Does that make sense? Okay.
My question is like -3 divided by -4.
Yes.
How is that 3/4? Is it because it's just not?
If you, okay, and this actually goes back to the very first night. All the way back to the very first night. Anytime you divide a negative by a negative or multiply a negative times a negative,
Yeah.
that becomes a positive.
And I get that, but why is it 3/4? It's not 3/4.
You can go.
This divided by this?
Yeah.
I mean, this divided by this? That is 3/4.
It is?
Yeah.
How? Maybe I'm just being stupid right now, but how do you know it's not if you put it in here?
What do you get when you put it in there?
Decimal?
Yeah, and what's the decimal?
0.75.
Yeah, change it back to a fraction.
How do I do that? The second.
The FD button.
Hold on, I gotta fix this or I can't.
That's fine.
go on.
No, that's fine.
This one is like more complicated on a calculator.
Okay. You said the which one? FD?
The FD button, you see it?
Do I click the second first?
Is it up above or is it right on the button?
I don't have to push the second, right? That's for something else. I just actually hit the button.
Yeah,
I
think you just push the button. Actually, you shouldn't have to hit enter. Let me take a look.
I feel so dumb, but.
No, it's okay. Yep, that's fine. Okay. Okay, you get that.
Yeah.
And then you're gonna put, oh yeah, it is second and then the PR.
It is, okay. Okay,
Oh.
I just, because I kept getting, of course, I didn't know how to.
Yeah, change it back.
Like math.
And if you think about, if you remember what
Please.
fractions mean, fractions just mean division. So when you see this, 3 divided by 4, and you do that in a count, it just means 3/4. It means the same thing.
Okay.
Okay? But you can do it on a calculator. It'll work. Okay? So again, perpendicular, we change the slope from this to this. Okay, that's hopefully the key. Can we go on?
Yeah, sorry.
All right. No, that's okay. All right. Now this one is going to be a little bit different. I'm going to leave my slope-intercept form up here because we're going to want to keep that in mind. Find the equation of a line through the point 4, -5 and parallel to this line. Okay, so we have to start with one thing at a time. Okay. first thing we need to know from this, since we want parallel to that, what do we need to know about this line?
The same.
What is the slope? Right? And so we do the same thing we just did on the last two problems. So what are we going to do first? We're trying to get this y by itself.
Minus 2x.
We got to cancel out the 2x. And the way we do that is subtract 2x. This is not a divided by sign. I just was underlining. So subtract 2x. So this cancels. And now we have negative 3y equals negative 2x plus 6. And then what do we need to do? Divide by negative 3. And we divide everything by negative 3. So now we have y. Remember, a negative divided by negative is a positive, and we can just leave that as 2 over 3, because the negatives basically just cancel out, and now it's 2 over 3, x, and then this ends up being minus 2. But what we care about here is, what is the slope?
2.
2 over 3. Okay? Now, if that's the original slope, and we want parallel to, what is our new slope going to be? 2 over 3. We just leave it alone. Parallel means keep going in the same direction. So our slope is going to be 2/3. And we've also got the point given to us. I didn't do it. We've got this point given to us. So when we know a point and we know a slope, we're going to use point-slope form. Now I'm going to write point-slope form up here so we can, and I will give you this equation, the general form of slope-intercept form, and I will give you this equation.
Is it the y minus y?
Yep. And I'll put that on your test so that you have it. Okay, I mean, you need to kind of know how to use it, but it will be there so you don't have to try and memorize it. Okay, so what we're going to do is we're just going to plug in these numbers. So y minus, remember this is x and this is y. So it'll be y minus y, which is
Minus.
negative 5, equals our slope m, which is 2/3. And then x minus the x value, which is 4. Okay? And they actually didn't specify how they wanted the answer written. We could actually stop right here. We've got the equation of the line. If you wanted to, you could keep going and simplify and convert it into slope-intercept form, but you don't have to. You can stop right here. The only thing I'd probably say is change that to adding a positive. Okay, so this is a line that has a slope of 2/3, so it's parallel to this one, and it goes through these points because that's what we put in there. Okay. And again, if we wanted to convert it, it's only 2 steps to go from here to slope-intercept form. We distribute to get rid of the parentheses, and then we subtract 5 to get rid of this 5 over here, and then it's y equals. And it's like this. Okay. Does that one make sense? Again, the new stuff for today, the new stuff is this. How do we find the slope from this line? And if it's parallel, the slopes are just the same. Okay. Are we okay to go on? It's been a rough day, evidently.
Everything counts.
All right, now this one, oh, how nice. Find the equation of a line through that point perpendicular to this. So we want perpendicular to. But what do we notice about this equation?
You already have your.
It's already in slope-intercept form, right? So what is the slope of this equation?
negative 3 over 5.
Negative 3 over 5. Is everybody okay recognizing that? Okay. So what is our new slope going to be? If we want perpendicular,
3 over 5.
5 by 3.
it'll be, we're going to change the sign, so it'll be a positive, and then
5 over 3.
5 divided by 3. 5 over 3. Okay. Okay, now this one, I did say to put it in slope-intercept form. So we are going to go back and we're going to use this to help us get started. Okay. So what do we know the y value is this time?
-9.
-9 equals, and then this is the slope 5/3.
So you use your new slope.
We use our new slope because that's
Fine.
going to make the line perpendicular.
Fine.
Why? Because that's how, because our goal was to find perpendicular to this.
Find the equation of the line through.
So it has to have two conditions. It has to go through this point and it
Oh,
has to be
okay.
perpendicular to.
Got it.
So the perpendicular to part is changing the slope from here to here.
Got it.
Okay. If it was parallel, then we'd leave the slope the same. We wouldn't change it. So we've got our slope, and then we're going to put in x minus 6. Now this time, like I said, I did say go ahead and put it in slope-intercept form. So, like I said, there's 2 steps here.
Okay.
Let's go ahead and fix the 9. Subtracting a negative is adding a positive. We've got to distribute. So y plus 9 equals, the first one just becomes 5/3 x. And then 5/3 times a -6 is going to be 10. If you're not sure about that, go ahead and try that on a calculator. 5/3 times 6. And that does equal 10. And no, I'm not going to be sitting there while you do your homework. So you need to make sure you know how to. I'm not going to go to your house and help you do your homework.
If we pay, maybe.
I'm afraid I'm probably too
Extra
busy
cash.
for that extra cash. So, and then what's our last step going to be?
Subtract 9.
Subtract 9. So that cancels here. We got y equals 5/3 times x, and then this would be minus 19. And the only reason I say that is you guys have to know how to use your calculators to get these answers, right? I can tell you the answer right now, but you've got to know that 5/3 times 6 is 10. And you can do that with your calculator. That, it should work. Okay. What's wrong? You don't believe me?
I mean, I don't.
Check your calculators.
We-
Maybe I'm having a bad day and I made a mistake.
No,
No, it's
I think
fine.
we don't need to use a calculator there because we can consider that.
But some people can't.
So some of us need to use a
Yeah.
calculator.
That's fine.
Sorry,
Some of us are not
Sally.
as smart as you, so
No, not smart. That's
that's okay.
okay.
All right.
If I have to press calculator, that's more confusing.
That's
for
more
me.
confusing. Okay,
Different brains.
are we okay to go on?
I don't want to use calculator.
Okay, overachiever.
Okay. Now this one is a little bit different.
Oh.
It says find the equation of the line through the point 3, 4 that is perpendicular to the line x equals -2. Well, here's the deal. And we learned about this last week.
Mhm.
What is true about this line x equals -2? It's a special line.
It goes.
It's here.
Like this.
It's vertical, right? So
We don't.
Burr.
this is a vertical line, right? It goes straight up and down. So since it goes straight up and down, I'm going to draw a picture to see if this will help us. 3, 4 looks like this. 1, 2, 3, and then 1, 2, 3, 4. So here's the point right here. Okay. So if we need it to be perpendicular to a vertical line, what kind of line is perpendicular to a vertical line? Right. So if this one's vertical, what does the perpendicular line look like? It's horizontal, right?
Mhm.
So it's going to be going through like this. And do you remember what the equation of that line would be?
Why?
It's y equals,
2.
and if you look at this point, what is it going to be? What are all the y's going to
3.
equal?
4.
4. Y is always equal to 4, right? Here, 0, 4. Remember we talked about this last week? -1, 4. This would be like 2, 4. So all the y values are 4 on that line.
Can't draw the thing as cute as yours.
What?
So, wait a
Your
second.
lining thingy is perfect. Let me.
The line is perfect.
So is that all we're looking for?
That's all we're looking for. Find the equation of the line that's perpendicular to this and through this. So there's not really any math. This is more of a concept you have to understand. Vertical and horizontal are perpendicular.
Um, become plus 2.
There's not really any math to do here. It's just the concept of knowing that horizontal and vertical are perpendicular to each other.
So the vertical, if it has to go like this, x equals -2, then we'll just go 1, 2, and that.
So here's the original line. The original line would have been over here. I didn't draw the original
Okay,
line.
just the,
But this-
okay,
This would have been the original line,
okay.
and we're just drawing the one that's perpendicular to it and goes through this point right here. The 3, 4 point.
X is 2, so y is 4.
Okay.
2, 4. No, y is 4. 0, 4. Why you put -4, -1?
I was just,
4.
if you remember last week, this is kind of how you, if you can't remember if it's an X or a Y, if you look at the points on the line, all the points on this line have this in common. The Y value is always 4.
Oh, you want to show they have.
I was just showing you, they're all 4s.
I see.
All the Y values are
But-
4s. The X's can change, but the Y is always 4.
But in a test, we don't need to do that, right?
No. You just need, this is our answer right here.
Y equal to-
Sorry, over explaining.
That's an equation.
That's an equation.
So
And if you
then
think about what that
y
equation
is
says, if you think slope-intercept form, what is it saying? Well, the slope, since we're not writing it, is 0. And that's what a horizontal line is, right? Slope is 0. And then the intercept is 4. So that one actually can be written in slope-intercept form. Just the 0 makes the X go away. Okay.
If it is by itself, it looks easy, but if you mix everything, I think like. Oh, it's
If you mix it all
complicated.
together. Yeah. So that's the end. You got 5 questions there from that assignment. Please don't wait till the last day. I know we all get busy. I understand it. But if possible, don't wait till the last day.